Okay, Dr. Revis here with Chem 111, and we're going to talk about Chapter 2, an overview. And if you've seen Chapter 1, it's going to look just like that in terms of how we talk about it. Very informal, just help you give you some tips about what to expect actually in this chapter. Okay? And again, if we say some things that we didn't mean to say, I'm just going to back up and say them again. All right? Here we go. Chapter 2, we're going to talk about atoms, molecules, and ions. And you'll learn when to use these. For example, let me warn you in advance, atoms and molecules tend to get used interchangeably. Don't let that frustrate you. Watch for it, expect it, it does happen. You'll know when to be very precise about whether it's exactly an atom or the molecule. But be aware that you will hear atoms and molecules and you'll say, well, what's the difference? You'll learn the difference. Okay, so be aware of that. Now, we're going to talk this thing called the atomic theory. And why are we going to talk about that? I'm going to talk about that because substance matter is composed of atoms. And so what happens is you have these atoms that come together and they keep coming together and they give you matter. And we're going to talk about how that happens. How do these atoms that are like marbles meet and form substances that we get to enjoy matter as matter? Okay, so that's what you're going to learn. We're also going to talk about what we call the evolution of it. In other words, how did it come about? So you're going to learn the names of a few brilliant scientists that really thought of all this. And then actually you're going to learn the names of the brilliant scientists that actually reported it to, and the other guys kind of got left behind. Yeah, that happens too in real life, by the way. Just the way it is. So you're going to learn the names of the people who were credited with this science. I tend not to hold you as too accountable for knowing all the history, but there's just a few key names that we expect you to kind of know as you go. You're going to learn these atomic structures and symbols, and again, I have notes in front of me to help keep me on track. But you're going to learn these atomic structures and symbols. Be very precise with the symbols. For example, sodium is capital N, small, lowercase a, not both caps. You want to get used to doing that already. If it's a superscript in chemistry, it must be a superscript. So don't get sloppy on that. If you mean to be a superscript, make sure you show it as a superscript. Because if it looks like something else, you will miss points because we're very precise about it. If it should be a subscript, make sure it's subscript. So exactly how you write these is going to be critical and important for the symbols. That brings us to the chemical formulas where we put together combinations of symbols. And in some cases, you will have these in parentheses, and in some cases, you will not. All of it matters. You got it? Leave nothing out, leave nothing to chance. All of it is very important to being able to write it, and you will get used to doing that. The periodic table. I really urge you to learn as much as you can from the periodic table. In my lectures, I try to tell you where you can find that on the periodic table so you don't have to memorize it, because the good news is we always give you a periodic table, and there's always one in your classrooms. That's how it is. So if you can learn how to read the periodic table, you'll do really well in chemistry because many of your answers are right there staring at you on the periodic table. Okay? And I try to tell you what they are and where they are and how it works. But learning the periodic table, if there's one thing you should really focus on, is learning how to read that periodic table. A lot of answers are right there in front of you for things we'll ask you. It's staring at you. Okay? Molecular and ionic compounds. The difference will be ionics have charges. Yep. And molecular don't. Now, they are composed of two materials where the charges come together and they counterbalance each other, and you don't exactly see the charge all the time, but they're really composed of charges. Okay? All right, so there are two charges sitting really close together in ionic compounds, and they cooperate in an ionic fashion. Molecular, they really overlap really well and say, forget about knowing who has a plus and minus charge. We're cool the way we are. So be aware of that. Ions tend to have some type of charge separation, and moleculars don't. You'll learn exactly the detail of that. So this is just to introduce you to the concepts to think about. So think ionic, ions when you think ionic compounds. Don't think so hard about ionics when it comes to molecular, and you'll learn how to do that. And chemical nomenclature. Names are very important. You will want to learn those. That's pure memorization. Okay? So hopefully those are some tips to get you going on chapter 2 and talk about atoms, molecules and ions. Very important to remember. You'll hear atoms and molecules used interchangeably. So you'll know when to be more precise about one or the other. The other thing you'll discover is that these things called atoms are composed of protons, neutrons, and electrons. Always. If you think atom, it's always protons, neutrons, and electrons. The three come together, and voila, you get an atom. More atoms come together, voila, you get compounds and other matter. Okay? You got it? So hopefully these are some tips to get you going in this chapter. There's some new terms that you'll have to memorize as well. Okay? And don't forget about things such as dimensional analysis. Dimensional analysis is a process you will practice throughout the course. All right? Take care.